Hello everyone and good day once again. Last meeting, rather last video, I've shown you how to program the IAS computer by Jan van Neumann. I was using three simple programs where different computations were done. In this video, I'm going to show you a program that is used to make decisions or a conditional branching program, also in the same IAS machine. Take note that in the IAS, we have two instructions that can be accommodated in one word. So our jump instructions will be jump to the left or jump to the right. Jump to the left is signified by jump mx 0 to 19, and jump to the right is signified by jump mx 20 to 39. And contrary to the analytical engine, we have a jump plus instruction, which can be used like the CF combinational card in the analytical engine. However, there's a difference in logic because CF is used like a jump minus. So therefore, we are going to change our logic also. Previously in the analytical engine, we assumed that the result is 0 and we check if our cutoff is greater than 37.9.49 by doing a subtraction. This time we will assume it's R, which is our else statement. R is equal to 1. And then if we check if it's positive, because if it's positive, then we do not change R is equal to 1. We do not change R as 1. We will let it remain as it is. If it's lesser than the 37.5, we will change it to 0. So I'm using here the same worksheet which I've shown you to compute uh, the Celsius equivalent of a Fahrenheit temperature. This time, we are going to determine if the temperature result, which is stored in M5, is, is within the range of fever for people, for human beings. Remember that when a person gets a temperature of Celsius of 37.5 or higher, then he is said to have fever. Anything lower will consider his temperature to be normal. So now let us add certain variables that we can use for the decision. So for example, 6 here, we can use 6 to assume a result of having fever. And 7, which is 0, is a result with without fever. We are going to make a decision on whether or not the resultant temperature is feverish or not. So now let us add another variable that can be used to store the cutoff of 37.5. Remember the cutoff is 37.5. Our final result will be stored in M9. So this final result is a decision. We assume the decision is 1 if the person is having fever, and the decision is 0 if he is normal. Okay, so we will have M6. This is M6. We also have M7 without fever. So AC. M8. M9 is our decision. M8 is our cutoff, and we will freeze the panes here. So since we are adding instructions, we will change our addresses. This is now 10L, this is 10R, this is 11L, this is 11R, this is 12L. We will remove this. So therefore, our first instruction will be jump to 10L. So remember that 0 to 19 is left. And we say jump 10 because the words 1 to 9 are data or variables. And 10L is the first official location of the valid instruction. So M5 is our resulting temperature. We will have a 12L, 12R, during which we are going to determine whether this is this is feverish or not. First, we are going to assume that this is with fever. So we are going to load M6. Okay. So this is the accumulator will become 1, and in 13L we store M9. This we are assuming that the decision is feverish. And then we will check if this our resulting temperature is beyond cutoff in 13 hour. In 13 hour, we can do this by doing a subtraction. Okay, we will do a subtraction of M5, which is our resulting temperature. This will become equal to this. Okay, and then we will subtract the cutoff 14 at 14L. So we'll say sub the cutoff is in M8. Okay, so what's this minus 37.5? It's 18. And then we will do a jump plus. If it's positive, our decision is correct. So in 14R, we'll jump to that to a halt. So we'll say we do not know the address yet, so we'll just leave it as jump plus. In 15L, we are going to change our decision from 1 to 0. So we are going to load M7, M7, and in 15R, we are going to store M7 to our final result, or final decision of M9. And in 16L, in 16L, we will stop by doing a jump of 16, 0 to 19, because this is F to the left. So this will be a jump plus of 0 to 6, 16L. So it's like a jump, but this time this is a jump plus. So let's trace this. So our temporary decision is M9 is 1, so we have fever. And we subtract 50, our cutoff, which is 37.5, from the resulting temperature. We will have 18. So we are going to jump plus. Afterwards, we are going to jump plus to 16L, which will just halt, which means our decision is correct. The person has fever. For example, if we are going to change, on the other hand, our input to 80. Okay, so the first thing to do is 80 minus 32. Then we will multiply it by 500 equals the result times 5 rather. No, this is equals 80 first. Okay. And then we will subtract the 32 from here. That's the sequence. And then we will multiply this by 5. And then we will divide this by 9. Okay. And then we will equal this with the result. But that's a store M5. Okay. Then likewise, we are still assuming that the temperature is feverish, so 1. Then we store the result to M9. And then we subtract uh, 37.5 from 26.67, which becomes a negative 10.833. Now, what follows is a jump plus, which means that it will only jump to the final line if the result is a positive. But since this is not positive, it will proceed to the next, which is load M7. So M7 is 0, and we store M9 to become 0, and it will proceed to 16L, which will hold. So this is correct. 26.67 is not feverish. Therefore, our decision is 0. On the contrary, 132 with Fahrenheit is equivalent to 55.55. That's a very high temperature. Our decision will be 1. In the next video, I'm going to show you how looping is done in the IAS as we have done looping in the analytical engine. Thanks very much for watching, and goodbye for now.